Welcome into my series on essential skills for AP Chemistry. In this series, I'm going to be breaking down the most important skills for you to have to be successful in AP Chemistry in the class and on the AP Chemistry exam. And then within each of those essential skills, sort of show the various ways in which they are applied throughout the course and create separate videos for each of those and show examples. So in this video, we're going to be covering the first skill, introducing the first skill, and then sort of showing the first application of that. So the first essential skill, arguably the most important skill for you to have in AP Chemistry, is being fluent with dimensional analysis and more specifically mole conversions. Okay, so first of all, you just want to make sure you know how to do dimensional analysis. So that's later in this video, we're going to cover how to do that if you don't know already. And then the main way that that applies to chemistry is with mole conversions. So you'll need to know how to do mole to particle conversions using Avogadro's number, and mole to gram and gram, especially mole to gram, gram to mole conversions using molar mass. You'll do that a lot. You'll need to know how to find empirical formula, including using combustion analysis, which is just an application of applying mole to gram conversions along with some other things. Okay, an example where we use kind of mole to particle conversions is when we convert from between like per mole and per particle. So the most common place that that occurs is when we're talking about like the energy of a photon versus the energy per mole of photons. Okay, that's going to involve sort of mole to particle conversions. Obviously, stoichiometry, that's a big one. So just regular stoichiometry problems involve mole conversions and dimensional analysis. Also knowing how to do with limiting reactants, we'll cover that. And then different applications of stoichiometry. So gas stoichiometry. Okay, so stoichiometry can be connected to gases, either using this conversion when we're at STP or using the ideal gas law when we are not at STP. And we'll look at examples of both of those later on in this series. Okay, and then also solution stoichiometry, which involves molarity, okay, which is related to moles. Okay, and there's a connection to where mole conversions can be connected to stoichiometry calculations involving aqueous solutions, and a very common example of that is a titration. You have thermostoichiometry, so stoichiometry problems that also involve heat, where you have to calculate how much heat is released when a certain amount of reactant is used up, or vice versa. Okay, and this can both be for actual chemical reactions and also phase changes like fusion and vaporization. And then lastly, you have electrolysis or electroplating, where you are sort of figuring out maybe how much time it takes to plate out a certain mass of a metal or vice versa, and that's a big long dimensional analysis calculation as well in electrochemistry. So a lot of different ways that this gets used throughout the course. So let's make sure from the get-go we understand the foundations of how to do dimensional analysis, which is what I'm going to cover now in the rest of this video.
All right, we're going to practice a dimensional analysis example sort of outside the context of chemistry, so you don't get bogged down by the chemistry lingo like moles, okay? But what we'll see is that this question is actually very similar to the essentially dimensional analysis calculations that you'll be doing with moles in chemistry. Okay, so with dimensional analysis, we're really just converting units, okay? Taking a number in one unit and getting it into a new unit, which will most likely change the number. Okay, so suppose a bakery sells bagels with an average mass of 75 grams. What is the total mass in kilograms of 2 dozen bagels from this bakery? So what we want the total mass in kilograms. That's what we want to end up with. And if we think about kind of what we know in this problem, well, we know the mass in grams of one bagel on average. So it seems like that's probably how we're going to get to kilograms, is find the total grams first. Okay? Because this is the average grams per one bagel. So then how do we get the total grams? Well, we need to know how many bagels we have. We need to know how many bagels we have, because we know the average mass in grams of one bagel, and we don't know how many bagels we have right now. We're not given the exact number of bagels, but we are given the number of dozen bagels. Okay, or let's just call this dozens. We're given the number of dozens. So we can convert from the number of dozens to the number of bagels, to the number of grams to the number of kilograms. And so let's identify what each of these conversions are. Well, 1 dozen is equal to 12 bagels, or 12 of whatever we're talking about. A dozen of whatever, dozen donuts, could be 12 donuts, etc. And then bagels to grams, well, that's maybe not a universal conversion, but in this particular case, we're saying that 1 bagel is equal to 75 grams, at least on average. And then grams to kilograms, you should know that there are 1,000 grams in 1 kilogram. Okay, so the way that we're going to do this is we're going to start with the dozens. How many dozen bagels do we have? We have 2. We have 2 dozen bagels. Okay, I'll write it as 2 dozen bagels. Okay, or 2 dozens, however you want to write it. And then what I'm going to do, I'm going to use this conversion that there are 12 bagels in 1 dozen, or 1 dozen bagels. And I'm going to set like a fraction. And basically whatever unit I start with, dozen, I'm going to now put that unit on the bottom in the next step, because I want to cancel that unit out. So this unit, it's implied that it's in the numerator. We don't really have a denominator for this first part. You can just write over 1 if that makes it easier to see that this is in the numerator. But we want to cancel that unit out, so I'm going to put dozen bagels, that unit on the bottom, and then the unit that I'm trying to convert to, bagels, on top. And then my conversion tells me there are 1 dozen bagels in 12 bagels, or 12 bagels in 1 dozen bagels. And again, when we set it up like that, the dozen bagels cancel, because anytime you have something on the top and bottom of a fraction, the same thing, it cancels out, even if it's a unit, the same way that a number would. So that would give us our number of bagels if we did 2 times 12, but now we're going to keep going to grams. Same process. What do I have on top here? Bagels. I want to put that on the bottom. And then the unit I'm trying to go to, grams, I'm going to put that on top. Well, what's my conversion? Well, my conversion is that 1 bagel is equivalent, at least on average, to 75 grams. So I put 1 with the bagel, 75 with the grams. the bagels cancel the unit. That's why I set it up like that. And then lastly, we're going to go grams to kilograms. Same process. I have grams on top. I want to cancel that. So I'm going to put grams on the bottom. I'm going to put kilograms on the top. And then the conversion is that 1,000 grams is equivalent to 1 kilogram. So I set it up like that. My grams cancel. And now all of my units have canceled except for kilograms, which is my desired unit. Okay, so that is why we set it up like that. We end up in the unit that we want. And then, again, these are just fractions. So we're just going to look at the numbers, multiply by the numbers that are along the top, divide by the numbers that are along the bottom. You can ignore any ones. You can include the ones if you want, but multiplying by 1, dividing by 1 doesn't change anything, so you don't need to include them. So what we're going to have here is we're going to have 2 times 12 times 75. No, I'm not going to include the 1. And then the only number that's not a 1 on the bottom is 1,000, so we're going to divide by 1,000. And when you do that, you should get 1.8 kilograms. 1.8 kilograms is the total mass in kilograms of 2 dozen bagels from this bakery, assuming that they're consistent with this average mass of 75 grams per bagel. Okay, now again, you might say this doesn't seem to have anything to do with chemistry, but this process you need to understand because, again, the process for doing mole conversions, which is one of the most important skills in AP chemistry, is very, very similar to this process that we just did in this problem.